Hello, I'm Dr. Derry Keats, a former professor of biology. And yes, I'm still here with you, still talking about the human endocrine system. And this time, we're going to look at something really cool, the adrenal glands, and how they sometimes give us superhuman strength. Remember that some of the components of the endocrine system are found within the alimentary system, and like the pancreas, the adrenal glands comprise one of these. The adrenal glands comprise a pair of glands that are located atop the kidneys. They're sometimes called the suprarenal glands. Supra meaning on top of or above, and renal referring to the kidney. A little bit of random information in humans. The right adrenal gland is triangular shaped and the left is half moon shaped. The adrenal glands are mainly responsible for releasing hormones and responsible to the thing that we call stress. In particular, the so-called fight or flight response. The adrenal glands produce hormones in two main categories. One is the corticosteroids, especially cortisol. The other is the catecholamines, which include epinephrine, aldosterone. Now, the hormone epinephrine is often referred to as adrenalin outside the United States, but in the US it's referred to as epinephrine because adrenaline is actually trademarked by a drug company. You can use either of these names and you'll probably find me mixing back and forth between the two. We are going to focus on adrenaline and aldosterone and their roles and effects on the body. Now let's look at adrenaline first. It's a relatively small molecule with a very large role to play in the body. It's both a hormone and a neurotransmitter, and it has numerous functions, of which we will discuss the main ones only. One of the key features of epinephrine is its ability to control or trigger some metabolic shifts in the body. As mentioned, it's responsible for the fight or flight response that we will shortly discuss in some detail. It affects a whole bunch of things, including the diameter of the air passages, the diameter of blood vessels. Heart rate is also affected by adrenaline, as is breathing rate. All this, of course, is related to the fight or flight response that we've been mentioning. Now, for those of you who are outside South Africa and who might think that the response I'm going to describe is common in South Africa, I need to say that the only place in the world I've ever been personally robbed was in Rome, Italy. And also for those not from South Africa, a tsotsi is a thief. Now, imagine you are walking along the beach walk in Durban, as I was a couple of years ago, and you suddenly find yourself facing 4 tsotsis with knives. This happened to me, despite this being one of the safest places in the world to walk. I was walking along, minding my own business, when I became aware of a classic robbery attempt about to unfold with me as the victim. There were 3 tsotsis standing off to the side, and another tsotsi who came at me from an angle in the front, calculated to send me in the midst of the other 3. They would then have knocked me down and taken my backpack with my beloved camera equipment. But I was carrying a soft plastic water bottle in my right hand. It was my only weapon. In a fraction of a second, due to adrenaline, my brain processed the situation. I smashed the plastic water bottle into the face of the attacker, causing him no harm, but distracting him. And in that instant, I booted it out of there. To make a long story short, I called the police, and they were on the scene within minutes, and they caught the tsotsis. But what happened in my body is the interesting part of this story. For my escape was made possible by the very gland that we're talking about here, the adrenal gland, and its hormones, particularly adrenaline. Now, perhaps you've had a similar experience, though hopefully not with tsotsis. Perhaps you were chased by a dog, threatened by a school bully, or even while just playing sports. So let's see how this works, and the role of epinephrine or adrenaline in this process. Stress acts as a trigger for its release, and I'm using the word stress here broadly. You breathe faster and deeper to get more oxygen into the bloodstream. The liver converts glycogen into glucose and releases it into the bloodstream to provide energy where it is needed. Your heart rate increases as does your blood pressure, to get blood more quickly to the brain and skeletal muscles. The blood vessels of your skeletal muscles, heart and brain dilate. That means they get wider, so you can get more blood to heart, brain, and those very skeletal muscles that you're going to use. On the other hand, the blood vessels of your skin and digestive system constrict. That means they get narrower, so that you can reduce the blood flow to those areas and increase its availability to the brain, heart, and skeletal muscles. The metabolic rate of cells in your brain and skeletal muscles increases, so more energy is available for heightened brain and muscular activity. Now, all this brain activity produces heightened awareness and readiness for violent muscular activity. Now, let's look closely at what we call this. You don't have to remember this, but maybe the discussion will help you understand the concept better. The American researcher Walter Bradford Cannon coined the term flight or flight in 1929. We've learned a lot about the responses and the triggers for fight or flight since then. So a group of medical researchers from Hawaii have suggested that you first freeze, the heightened awareness phase, then the most appropriate action is actually flight, not fight. And it's only if flight is not available that fight is appropriate. Fright is playing dead, and it's quite common in animals that are unable to flee or fight in stressful situations. I think we use it too sometimes. Hence, they've suggested that the response be renamed freeze, flight, fight, or fright instead of fight or flight. So, now we have flight or fight with the other two elements, freeze and fright, which better describes the response, even if you do still use the term fight or flight, like most people do. The adrenal glands affect function of the kidney by secreting the hormone aldosterone, which regulates the osmolarity of the blood plasma. Now remember that the osmolarity is just a measure of dissolved salts, in this case mainly sodium. Remember also that the blood plasma is the liquid component of the blood. Now the pituitary gland also has a role to play, as it releases adrenocorticotropic hormone, or ACTH, also known as corticotropin. This stimulates the adrenal gland to release aldosterone. Now let's imagine we start with a normal sodium concentration in the blood, and for some reason the sodium ion concentration decreases. Under the watchful eye of the pituitary gland, ACTH is released, and this causes aldosterone secretion to increase. This causes an increase in the sodium ion resorption, more of it is taken up, and a decrease in the excretion of sodium ions. Since sodium is being taken up and retained better, sodium ion concentration increases in the blood, and so the normal sodium concentration of the blood is restored. But what happens if the sodium ion concentration increases? Aldosterone secretion is decreased. There is a decrease in the sodium ion resorption and an increase in sodium ion excretion. So less is taken up and more is passed out. Since sodium is not taken up as much and it's actively excreted, the sodium ion concentration decreases and the normal sodium concentration of the blood is restored. All of this happens because of the interaction between the hormones of the pituitary gland, ACTH, and the adrenal glands, aldosterone. Now there's also a role for the autonomous nervous system in interacting with these hormones, and this is illustrated by looking at the maintenance of blood pressure, which is effectively what we just described. In the graph shown here, the normal blood pressure is shown on the y-axis, with the pink line indicating normal blood pressure. Imagine that blood pressure drops for some reason. This is detected by stretch receptors in the carotid artery of the heart. A neural signal ultimately reaches the pituitary gland, which then releases ACTH. This reaches the adrenal gland and causes the release of aldosterone. This produces an increase in sodium ion resorption and a decrease in sodium ion excretion, as we just described, and blood pressure is restored to normal levels. In effect, we have taken a turn of the upper of these feedback loops that we described in the previous scene. Now, we've pretty much covered what you need to know for the South African grade 12 syllabus on this subject. If you want to take it further and have a deeper understanding, you could search Google or another search engine using terms such as adrenal glands, adrenaline, epinephrine, fight or flight, aldosterone, or any of the other terms that we've talked about in this video. You could also look for videos on this and related subjects on YouTube or on other sources of video material. You can even visit the local library or the school library and read up on these topics in good old-fashioned books, something I love doing. If you want to get creative, and if you can interview a member of the family or a family friend or an acquaintance, someone you know, about stressful situations that they got out of because of adrenaline. If you ask their permission first, you could even record the interview using your cell phone, either as audio alone or with video if your phone has that capability. You can, again with the permission of the person you interview or the teacher, upload the video into your e-learning system and share it with your teacher and fellow learners. Do you know anyone who is into extreme sports, an adrenaline junkie? You could even interview them about the effects of adrenaline and how they feel them when they're doing their extreme sports. And that's it. I'm Derek Keats, and this resource is licensed under a Creative Commons Attribution license.